Okay, good morning, everyone, and welcome to the first ever webinar for the Metro Alliance of Career Readiness Organizations. Today, we are joined by Amanda Hatherly, the CEO for Building Performance Institute, who will be talking to existing trades programs about how they can integrate building science principles as part of their curriculum. As we get started, please feel free to use the chat to introduce yourself and your organization. We're always interested at who all's joining in the conversation. And I want to give you a reminder that today's webinar is being recorded and we will share it out afterwards as part of our follow-up. Giving some introductions, my name is Jordan D. Rinkin. I am the current board chair of the Metro Alliance Career Readiness Organizations, or MACRO, and I'm also the Workforce Development Program Manager for Energy Outreach Colorado. And we'll be joined today by Amanda Hatherly, who will come on to talk about Building Performance Institute. But before we get into that, I wanted to do some table setting. First of all, what is MACRO? If you're joining us for the first time today, MACRO is a community of non-traditional post-secondary workforce training organizations, K-12 post-secondary system partners, and workforce centers and organizations. And when we talk about non-traditional post-secondary workforce training organizations, this includes entities such as labor unions, trade associations, pre-apprenticeships, employer-sponsored registered apprenticeships, trade and technical schools, community colleges, other short-term training programs, and justice-involved organizations. The Metro Alliance of Career Readiness Organizations brings these non-traditional training organizations together so that they can better integrate with the K-12 and other post-secondary system partners, as well as workforce centers and organizations that are supporting them. And this is a current list of the macro community. We are growing all the time and have a lot of support for what we're trying to do. So if you haven't had the opportunity to join the macro community yet, please feel free. Diving into what is macro, I wanted to dig into those non-traditional post-secondary workforce training organizations, because right now there is a lot of funding coming in to support the growth of specific careers in things like construction skilled trades, healthcare, advanced manufacturing, transportation, and the service industry. And at the end of the day, these career pathways are largely served by these non-traditional post-secondary workforce training organizations. Specifically today, we're going to dig into the construction and skilled trade sector and how they can better serve their participants by including additional curriculum such as BPI credentials in order to prepare their participants for not just commercial new construction work, but residential reconstruction work as well. And we're going to dig into that now. First of all, I am someone who works in the construction sector. With my role at Energy Outreach Colorado, I do try to grow the trades for the largely residential reconstruction sector, primarily in an electrical, HVAC, plumbing, insulation, energy auditing, weatherization, electrification, and more. And as I've come to work with these trades, it's become very apparent to me that there's not a good understanding of a very important dichotomy within the construction trades, specifically between new construction and reconstruction, which is also sometimes referred to as retrofitting, rehabilitation, or renovations. So with new construction, what you think about is a new building or structure from being made from scratch, typically on a vacant or cleared lot. In fact, in your mind's eye, if you think about new construction, you probably see giant cranes and big heavy equipment at a job site building a giant high rise. And that's exactly part of the problem with not understanding this dichotomy. Some of the core characteristics around new construction is that it's a blank slate, so there are few unknowns once site prep is complete. There's predictable sequencing, it's code forward, so you're always building new buildings to the existing building and energy standards. It's design driven, and it's got higher standardization. These have important workforce implications, such as having easier to train entry-level workers, more forgiving of inexperience if supervision is solid, trades work in isolated scopes, and productivity and speed are heavily rewarded. On the other side of the coin, you have reconstruction, and this has a very distinct difference with new construction. This is work that's performed on or within an existing building, which are often, while it is occupied, and non-compliant with modern codes. The core characteristics of reconstruction work involve high uncertainty and hidden conditions, which are common once you begin work. Sequencing complexity. Trades must coordinate with each other in order to perform building upgrades. They're constraint heavy because you have space and access which is limited by existing and obsolete and outdated systems. It's performance driven, so there are outcomes such as comfort, safety, and efficiency which matter as much as making sure that the work you're doing is being done to code. And finally, it's human centered. Your work is often done in people's homes, which is one of the most private places we have in our lives. So it takes an extra amount of soft skills and communication to effectively work with someone within their own household. This has huge workforce implications, specifically that it requires higher diagnostic skill. And I put that in italics because that's going to be the big difference that we dig into, and one of the big opportunities that comes with incorporating Building Performance Institute standards within existing construction trades programs. There are fewer plug-and-play tasks, and there's strong demand for problem solving, systems thinking, cross-trade communication. And finally, a much higher risk of rework if you make mistakes the first time. Digging into this dichotomy, some of the implications of a lack of this understanding is that when training programs, such as pre-apprenticeships, implicitly frame construction as just new construction, their program participants are being prepared for only a fraction of the labor market. Right now, reconstruction is where many of the most accessible, stable, and immediately hire-ready jobs exist, such as opportunities in weatherization, energy efficiency, and building performance, as well as opportunities in electrification and emerging technologies such as solar, EVSE, and heat pumps. The key skills and knowledge differentiating work between new construction and reconstruction is diagnostics. And that core distinction between the two, new construction's executing a plan which is designed to meet all existing building and energy codes. So you know from the start that you're supposed to get where you're supposed to be. Reconstruction is diagnosing a building before it acts. And then you continue to diagnose as it goes in order to upgrade an existing building so that it can meet new building and energy codes. And finally, let's dig into why diagnostics is so core to this work. For every existing building, it's unique, it's aged, it's been modified over time, it's partially undocumented what modifications have been done, and they're often degraded. You're dealing with things that can include hidden conditions, unknown sequencing, and interacting with systems such as the building envelope, the HVAC system, the electrical system, and moisture control. Diagnostics is required to answer, where is the heat being lost? Why is this room cold? And is this furnace safe to use? What happens if we air seal? Will electrification overload the panel? And is there moisture risk? So with that background information and table setting behind us, I can now introduce you to our featured guest, Amanda Hatherly and the Building Performance Institute. Reconstruction requires diagnostics, and BPI is the closest thing the industry has to a shared language, standard, and credential for doing that type of work properly. Building Performance Institute is a credentialing and standards organization focused on building science, energy efficiency, and health and safety in existing homes. And in workforce terms, BPI translates diagnostics from an abstract idea into teachable, testable, and certifiable competencies. And with that, I'm excited to hand this off to Amanda Hatherly of BPI. Amanda?
Thanks, Jordan. Hi, everybody. It's so nice to be here. I'm Amanda Hatherly. So next slide, because I think you're going to be advancing in me. That's me. I just also want to let you know, Katie Gonzalez, who's our technical director, she just came on fairly recently. She's fabulous. She's in the on this meeting with you also. Katie, maybe you'd put your email in the chat as we're going through this. If you have any technical questions or you want more information, feel free to reach out to either of us. Next slide. And at the end, if you have questions for her, feel free to ask them. Just a tiny bit about Building Performance Institute, because people get us, think that we're a training organization. We're a nonprofit. Next slide. We develop ANSI standards and certifications, and this is what gives the credibility to the standards that we have and the certifications that they've developed by the subject matter experts from around the industry that have to come to consensus on the standards and the credentials that we offer, so that organizations like federal government, state, local organizations have a comfort level in calling out our credentials because of that ANSI ANAB accreditation that we have. And next slide. We do not do training. We have training partners around the country that do training. For example, I know Blue Sky's on this call, and I think there might have been someone else who put their name in the chat. I can't remember. Next slide. So just there's one of our ANSI standards for basic analysis of buildings. We offer professional certifications. We offer certificates that can be earned online, and that's really what I'm going to be talking about today. And then we also have contractors. Those are organizations, companies that sign up with us to be a Gold Star contractor, and they have to attest to upholding standards and a bunch of other things that are required to be able to call themselves Gold Star contractors. Next slide. So here's the problem, and Jordan alluded to some of this. There are 143 million existing homes out there right now. Many of them have poor insulation, bad indoor air quality, they're old systems, drafty, leaky, wasting a lot of energy. And next slide. The industry's changing. So up until fairly recently, everything has sort of been siloed. So we've had in the trades, we've had HVAC, we've had plumbing, electrical, and construction. And I worked at a community college for many years, and those were the different trades that people would engage with. At my community college, a basis for all of those was that they had to take what I'm going to talk about today, which is building science principles, to have it as a basis of all of the work they were doing. Because now we have, as Jordan mentioned, the need for looking at homes differently with the push for energy efficiency and electrification, climate resilience issues. Instead of just looking at like an HVAC as a standalone trade, or construction, new or existing as standalone pieces of information, you have to be able to cross-reference a lot of different information around basics of building science to be able to work in those trades effectively. And next slide. So for us and for everything that we do at BPI, and including our building science principles, we look at the house as a system. We don't look at it as just the individual components. So we have the building envelope, and that's usually where the construction trades come in. We have the mechanical systems, and that's usually like the HVAC trades, electrical, and then there's obviously the occupants. There's the environment outside, which has a huge impact on the environment inside, and more. And so when we are looking at how you understand homes, and we typically just work with existing homes, all of those components are the knowledge that you really need to be able to go into a house and work on any system. You do have to have an understanding of all of those systems. So next slide, here's the training gap. As I mentioned, we had all those different silos, and now though, with the building science principles as a basis, it can basically inform all of those different trades. And there was one more slide I think didn't make it in there. It was a slide that I had put in to explain, for example, in the HVAC trade, up until now, we've had, you're putting in a furnace in a new home, and as Jordan mentioned, that home's been designed for the furnace. And then you'd go into that home as an HVAC technician, and you'd diagnose problems with that furnace and you'd fix it, or you'd go back in and you'd service it, or if it gave up the ghost, you'd go replace it with a new furnace. Same with a steam boiler, for example. But now we're asking these people to go from a furnace to a heat pump or a boiler to a heat pump. And that's a skill set of being able to look at the whole home holistically, because now you're not just going and putting in a like-for-like piece of equipment. That house wasn't designed for the equipment that you're going to be putting in. And so you have to now be able to understand, how's that going to affect the insulation or the moisture levels in the home, or this is how all these systems going to work together. And that's why building science really has to inform all the different trades. Next slide. So here is the building science principles. We have a really nice reference guide, which is both digital and in a hard copy format. And then at the end, when someone has passed the exam, they get a certificate of knowledge from BPI. And so I'll go through what's in our building science principles course. First of all, there's a section on heat flow. So obviously, we're going to be looking at thermodynamics, and heat flow is obviously a key one. How does heat move through the building, and things like insulation and the implications of insulation on a home. Next is airflow. Same is you've got to be the technician or whoever's going into that home, whether they're a contractor going in, whether they're an auditor, whether they're an HVAC, electrical, they really need to understand where's air moving in that home, especially as we make houses more airtight because of the need for energy efficiency. You have to understand what's the implication of the airflow or the less airflow in that home. Next is moisture flow. Same thing, you need to understand how moisture moves through the house. Next is the mechanical systems, and in our building science principles, this also includes hot water systems as well as all the HVAC systems in the home. Lastly, home performance and conservation, which goes more into some of the systems in your home, like lighting, appliances, making energy efficiency improvements, how that impacts your house, and also there's some information about solar in there. And here is a breakdown of that building science principles. We have the reference guide. It's available in English and Spanish, and the exam also is available in English and Spanish. There's no prerequisites. There's an open book online exam that's not proctored. And at the end, you get this nationally recognized certificate. So when people offer this, sometimes they'll do a one-day training. Some days they'll do a 3-day training, depending on the level of knowledge that they want the students to have. When I used to teach this at a trade school and a community college, we did it as a one-credit course through half a semester. And because there were these different principles that we were working our way through, every week we'd have a different component of the course, and then the students would go back and have to apply that to their own home and like try and understand like what's happening with the insulation in my house. Can I even figure out what it might be? And so that was how we did it. But it's done online in courses. It really is up to the people that are teaching the course to determine how they want to deliver that content. Next, so here's how you can integrate it. This can be foundational for pre-apprenticeships, embedded into existing programs like we did at the community college I worked at. It was a requirement for all the trades courses. We also did do it as a high school dual credit course. As I mentioned, online, in person, can be very interactive, or it can be more lecture style. And that really is however the model is of the organization that's doing the training. Next slide. And so outcomes, the students in your programs will have better problem solving skills, because as Jordan mentioned, a lot of this it's not cookie cutter, like you learn the different skills and you learn the different information. A lot of it is putting things into context, working almost like a detective, like solving one problem in a house, like making a house more airtight, might create another problem somewhere else in the house by, for example, trapping moisture in a bathroom, and now because the fan isn't working, you've got mold issues, and then that might, solving the bath fan issues there might create another problem somewhere else in the house. So it's like looking at a house and figuring out all the different things that might happen by making changes in your home. So it gives them a better understanding of what it's like in the real world and expands their career opportunities. Next slide. So for programs, this aligns programs with the industry needs, because as Jordan mentioned, this is really key right now, is that a lot of programs out there are looking for people that can work in a more holistic way in looking at electrification and energy efficiency. And then it differentiates your program for funding and partnerships, because now you're offering something that you can kind of call out as a national credential. And it offers the opportunity to have students that leave with stackable credentials. So it connects to, as I mentioned, HVAC and mechanical is a really good use case. And then this is core for anyone working in weatherization and energy efficiency. All the federal state programs pretty much that call out working in energy efficiency programs will call out some of the BPI certifications. I'll talk about some of them later, but this building science principles is the core of all of our credentials. Helps with electrification projects and obviously energy auditing, building performance. So if you're going to get started, you'd identify where it might fit in your program. And at my previous job, community college trade school, we identified it as core to all of them. So everyone had to take it as mandatory in their career pathways. Instructors could take the course themselves, read the book, take the exam themselves, adopt it into their curriculum. I think anyone working in the trades would find a lot of this sort of intuitive, but then there's whole chunks of it that you may not have been exposed to if you've been working in one component of this. You just haven't really examined some of the other components. So you can go through the course yourself, develop your own materials, and then offer it as a credential to students. Next slide, other opportunities. Okay, so then we just go forward. So we also have a very similar course, or actually certificate of knowledge called Healthy Housing Principles. And that takes similar sort of a style to the building science principles, but looks at the impacts of what's going on in a house and how it affects your health. And this one, every student that we had that took this, it's just like their eyes open, looking at like what goes on in their personal house, as well as, how they can use this going forward. So if you haven't seen this before, there's sections, for example, about the implications of keeping a house dry, keeping it contaminant-free, keeping it pest-free, keeping it clean, and how this affects the health. And this relates to existing homes. It's entry level. It's available in Spanish and English. We do have a very detailed reference guide that go along with this. That is not available in Spanish. It's just in English. And like the building science principles, this also has no prerequisites. After that, we have also a certificate of knowledge called Cold Climate Air Source Heat Pump Assessor. And this was developed with funding from an organization called TRC. They funded us to develop this because they realized that they were working with a lot of contractors that, as I mentioned, they were good at either the assessment piece of a house for looking at a furnace to furnace, or air conditioner to air conditioner, or boiler to boiler, but they really didn't have that extra piece of going from some traditional equipment to a heat pump, and specifically a cold climate air source heat pump. So this is a certificate of knowledge. It's open book and online. There are prerequisites, but the prerequisites are either holding other BPI credentials or having, I think it might be a year of community college or trade school, so that you have a background. You're not just going in completely cold to heat pump systems, or been working in the field for some time. And we have one called Total Building Performance Certificate of Knowledge. This one is for people who are looking to learn more about deep energy retrofits. There's training materials for this online that are free to access for anybody, and then a certificate of knowledge. And this one also is open book, it's unprompted, but it does have some prerequisites. And the next step after this is to work to offer our certifications. Typically, you do have some kind of hands-on training center that has got, for example, combustion equipment. You are going to be using diagnostic equipment with students like blower doors, and the ones that we have are building analyst technician. We have one called AC and heat pump. We have ones that work with the weatherization program, the federal program, which is energy auditor, quality control inspector. And we do have other certifications, but to offer this, you have to, at that stage, become a BPI test center where you're agreeing to uphold the exams, work with a proctor that is also upholding our exams. And so the ones I mentioned prior to this, those are ones where you don't have to be a BPI test center. You can just offer those as credentials to students, but once we get into the more advanced certifications, you do have to work with us to become a test center. And that's it. So what questions or discussion might you have? And I'd also like to ask Katie to jump in if there are questions that might be helpful for her to answer.
And please feel free to come off mute.
Is there a cost? Yes, the exams, I think the exams are maybe $109. The books are, depending if it's a hard copy or a digital copy, are $149 for the hard copy and maybe $119 or something for the digital copy. So yeah, that's the cost for the student or the program. And then if you become a test center, those the exams are sort of a flat fee that we sell for the test center, and the test center and for the coursework, you make up your own charge if there's an additional charge for students there. We don't get involved at all with any training fees. We just determine the testing fees. Someone put something else in. Let me see where the chat is. Can you read the chat? If there was, oh, here we go. Let me see. Oh, and Katie put the link to the both of those, and also, let's see. Yeah, Katie put in some more information. Antsy, thanks, yeah, for putting that in. What other questions do you have?
Amanda, I don't have a question, but I do want to throw out that the building science principles, we found that people want that to be offered to the whole construction crew, including the folks working in the office, the whole team, because it gives you a lingo to be able to talk about, the trade. So we've really started pushing it for everybody, like you said. It's sort of the best part of all of the building science world, and that beginning part with the principles. So anybody that needs to understand the lingo of construction or how all these industries cross each other, I just wanted to throw that in. It seems very helpful to way more than who we thought it would to begin with.
That's a really great point, Scott. We did offer it to people outside of the sort of traditional construction trades industry too. We had a lot of realtors take it. And they found it fascinating.
Yeah, I bet so.
Yeah, I can add to that definitely administrative staff in particular who are interacting and interfacing with customers or homeowners, super helpful for them to kind of understand those core concepts and be able to communicate that with a lay person who maybe isn't as familiar.
Right. And I'd add for any of our K-12 colleagues who are here today, as a former high school physics teacher, building science principles is literally just applied physics. It's everything that you learn in physics, in fact. And I wish I'd known and taken building science principles 10 years ago when I taught this class, because in physics, we still teach them a lot of abstract problems, and building science principles offers a way for you to teach physical concepts that students then can go home and see in their own households as well. And as for like pre-apprenticeships, I also just want to really emphasize what Scott mentioned about how building science principles can serve as a roadmap for an interested person, really seeing which part of the trade ecosystem they want to go into. Because a lot of times people are being pushed into electrical or HVAC without really getting their hands dirty and seeing that, oh, maybe I want to be a carpenter instead. So with building science principles, you kind of get to see the full lay of the land before you really start specializing.
Mhm. Yeah, and we did offer it at my community college as a dual credit with for high school students, and they loved building science principles.
Yeah, I have to piggyback off of Jordan. Thank you for the invite, by the way, Jordan. And yeah, my name is Tamal Saba. I'm owner and design build general contractor for Apex Energy USA. We lead a nonprofit here in Colorado and mentor and refugees, teach them English, over the top English, get them pre-apprentice work in mechanical, electrical, plumbing into Fortune 100 companies. Found Jordan as another outlet because we couldn't get all of our guys and gals into those so easily with politics and all. But, you know, you guys are giving us a door where we can bring in educated refugees, educated from Afghanistan that work with Army Corps and DOD and State Department, you know, in the camps where I worked for 5 years in Afghanistan. So we could try to integrate that. But what I want to do is, and ask you this, Amanda, is if I bring 5 refugees, for example, and pay for that service and want them to go to the tech center, because we have a teach by tech center that we get them to teach them power tools, what have you. It's the same thing what you're doing, giving them and integrating into another idea, implementation of construction. So what can I about 3 out of 5 will know English and understand you. Some of them I'll have to maybe try to translate a little bit, or maybe have somebody there to translate for them a little bit.
Mhm.
That be okay?
Yes, that's completely okay. And in fact, with the building science principles, we would often, there was a program I worked with in San Diego, and they would have a group of students who were struggling with reading and writing, and they would do the whole class with them. And then at the end, when they took the exam, someone would read out the question and help with any translation, help with anything, so that we're completely fine with that.
Well, what I like to do is, and I like to respect your rules, but oversee it for you and make sure to facilitate what they need, so you guys don't have a disconnect. Okay. I'm very good with numbers, and I'm very good with languages. Okay. So I can bring it to the table, and just break the barriers, if you will. Okay.
Yeah, absolutely. We love
think
that.
the third world all the time, you know, they don't think, you know, and we just need to, we're just human. So we're all just need to get along and understand each other. But yeah, I have this is a piggyback off a data center experience, off a commercial industrial type of programs where, you know, I've learned for 3 years how to freeze liquid at 72 degrees and help with heat pumps in California electricity. It's coming here to Colorado. So I'd like to integrate and help you guys. I mean, I think Jordan will really appreciate what I'm offering, but we might be able to piggyback off of the heat pump and get maybe more of a disadvantaged communities area. They're giving more tax credits and what have you, and for your energy, you know, consumptions. And I want to work with you guys more on that. Okay.
Great. Yeah, I think connect with Jordan for sure.
No, I will.
Yeah, and then anything we can do to help facilitate, of course, with.
No, appreciate what you do. Thank you so much.
Yeah.
Any other questions from our audience here? All right, well, we are coming up on time here, so thank you all for being willing to stop and learn. And thank you, Amanda, for coming here and sharing with us. I just want to, again, emphasize, if you have an existing construction program, you are already teaching the same skills that's going to be needed in reconstruction, with a slight perspective shift of incorporating things that we talked about today. You can offer your participants increased labor opportunities.
Thank you guys.
And please reach out if you have questions.
Thank
Katie or
you.
me.
Appreciate you. Have a great day.
Bye.